Now we're moving on to 21.5, Uses of Radioisotopes. And here we're going to list common applications of radioactive isotopes. So one of the first things that we might do with them is we can replace one or more atoms in a compound with radioisotopes, and we call these compounds radioactive tracers or radioactive labels. And this allows us to track them by monitoring their radioactive emissions. So we can use this to follow the path of a biochemical reaction or determine how a substance is distributed in an organism. It's also used for diagnoses and treatment of medical conditions, to measure engine wear, and analyzing geological formation around oil wells, and many more. Your book goes into a little bit more detail about radioisotopes and medical practice. For instance, technetium-99, thallium-201, iodine-131, and sodium-24 are used as radioactive tracers. Technetium-99, for instance, is used to detect damaged tissues in the heart, liver, and lungs. Thallium-201 becomes concentrated in healthy heart tissue. Iodine-131 concentrates in the thyroid gland, the liver, and some areas of the brain. And salt solutions with sodium-24 can be injected into the bloodstream to locate obstructions to the flow of blood. So just some examples. A lot of times these medical radioisotopes, they'll have very short half-life. Technetium-99, for one, has a half-life of only 6.01 hours, so they can't really make it and store it. So it has to be made on site. The hospitals tend to use molybdenum-99, which actually comes from uranium-235 fission, and they use that to make technetium-99 by having it undergo beta decay, because it has a half-life of 66 hours. And then they chemically extract the technetium-99. Now, we also have radiation therapy. And this uses high energy radiation to damage the DNA of cancer cells, killing them or keeping them from dividing. So there's two main types. We have external beam radiation therapy, which is done with a machine outside of the body, so it directs the radiation from the outside, and internal radiation therapy, or brachytherapy, which has a radioactive substance that's introduced into the body. Now, this is not to be confused with chemotherapy. It's similar to internal radiation because it's injected into the body, but it actually uses chemical mechanisms rather than radioactive substances to kill cancer cells. So this is why chemotherapy and radiation might be used in conjunction with each other for cancer treatment. My grandfather actually, before he passed, he had lung cancer, and so he underwent chemo and radiation, and so he had the external radiation therapy, so he had a little tattoo that they put on him right where they were going to be directing the beam for the radiation. It was pretty interesting. Here's a picture of a patient getting thallium-201 and performing a stress test. So this lets them visually analyze heart function and blood flow. This is showing technetium-99 being generated in A, and that's using what's called column chromatography to separate it from the molybdenum-99. So the molybdenate ion stays in the column, so basically it makes one thing stick to it, another one can pass through and be collected. And then in B, that is a technetium-99 being used in the scan of the neck of a patient that has Graves' disease, and it's showing where the high concentrations of the technetium-99 are. Here this is showing using a cobalt-60 machine for the treatment of cancer. So it focuses the radiation on the targeted region. That's like I was talking about with my grandfather. He had a little tattoo, so it knows where to go. So this also minimizes the amount of radiation passing through nearby regions of the body. So that, because the radiation doesn't just kill cancer cells, it's going to kill whatever the cells it sees. So by directing it, it minimizes that. And this is showing cobalt-60's series of radioactive decays. And those gamma emissions themselves are what is used for the radiation therapy. So some other uses, they're often used to study the mechanisms of chemical reactions in plants and animals. For instance, you can label fertilizers to study how a nutrient from fertilizer is taken up by plants, and crop growth, not growth. I don't know what growth is, but also for investigating digestive and milk producing processes in cows. Study the growth and metabolism of animals and plants. And actually, carbon-14 was used to label CO2 and watch the process of photosynthesis. So they were able to see, take samples at different intervals of the plants to determine which organic compounds had this carbon-14 and how much of each was present. So then they were able to figure out the pathway of photosynthesis. There's also commercial uses for radioactive materials. For instance, they're used to determine the thickness of films and thin metal sheets by using the penetration power of different radiation types. So they can see how far the radiation goes into a thin metal sheet, for instance. If it stops, so far in, then they know, okay, it's, this is the thickness because the radiation couldn't get through, for instance. They might also use it to find flaws in metals for structural purposes. So they shoot higher energy gamma rays produced from cobalt-60, and they can use that to find flaws in the metals, which could be very bad when it comes to structure. What I thought was interesting was pest control. So they use gamma radiation to sterilize male flies so that their offspring, if they were to mate with a female, they don't make any offspring because they're sterile. It also can be used to preserve food by killing the microorganisms that would cause it to spoil. It's also, radiation. We use X-ray examination of luggage at airports. And then americium-241 is used in ionization type smoke detectors. And I'll show a picture of that in a second. But in A, you can see X-ray examination of luggage at an airport. It's not just normal X-rays. So this is part of the reason why, you don't want to go through the X-ray machine, that you put your luggage into, or if you have an animal with you, do not put them on the X-ray thing because they're being exposed to radiation. Also used for preserving food. And then here's a schematic of a smoke detector. So what happens is you have this little ionization chamber. That's this guy here. Kind of looks like a battery. And you have americium that's emitting some alpha particles that ionize the air. So it gives this air some charge, making a current. So then we have a negative and a positive plate, so we actually have a small current going on in here. Now, if there's some smoke, though, the smoke gets in the way, and it keeps the ions from flowing, which reduces the current that's produced, and then it triggers an alarm to say, hey, there's no current. So this is why, if you're cooking and you make smoke in the house, and then you got to get it to clear so the alarm shuts off. So now you got the current back. I might be speaking from experience. I may have made some smoke the other day in my kitchen. Don't forget to turn your vent fan on, kids. But I thought this was really cool.